In mathematics, many operations have inverses. These are operations that undo each other. For instance, division and multiplication, or addition and subtraction. So we're going to be looking through now, as we go into this next phase of calculus, is we're going to be exploring the inverse operation of a derivative, which rather not uniquely is called the antiderivative. So an antiderivative is a function, okay, that when you take its derivative gives you the function you're looking at. So if I'm looking for the antiderivative of some function f of x, little f of x, okay, I'm looking for a function that when I take the derivative of it, that's what I get, little f of x. It's kind of using the derivative itself to define the antiderivative. But the idea is when you have an antiderivative, if when you take the derivative, you get what you originally wanted, that's how it works. So let's take a look at a couple of examples so that we can see how this works, okay? So first we want to do is we want to find the antiderivative of 2x, okay? So in other words, 2x is the derivative of some kind of function, all right? So if I take the derivative of some function that I know is going to be k times x to some power, right? Because obviously if it's 2x, I'm dealing with polynomials, I'm dealing with the power rule, okay? So now then, so when I take the derivative of this k times x to the n, okay, what I do is I take the k and I write it down, I multiply it by my exponent, and then I take my exponent and I decrease it by 1. All right, so realize these two things right here, 2x and k times n times x to the n minus 1, okay, those two things are equal to each other. So what that means is that k times n is equal to 2, and n to the negative 1 is equal to my exponent on x, which I know is 1. Okay? So with these two pieces of information, I can figure out what k is, I can figure out what n is, and that's going to find me my antiderivative. Okay? So let's see here. Actually, I'll start with 1. So I know that n minus 1 is equal to 1. Okay? Well, that tells me that n is equal to 2. So I know my exponent is 2. The other thing that I know is, I said k times n is equal to 2. Well, I know that n, I've already figured out, is equal to 2. That's equal to 2. Therefore, I know that k must be equal to 1. And so my antiderivative in this case is 1 times x to the second power. In other words, the antiderivative is x squared. Okay? And sure enough, if I take the derivative of x squared, right, I would get 2x. All right, let's take a look at another one. Now I have 10 times x to the 9th. Okay, this is another situation where I know this is a power rule because I have a variable raised to a power. So if I take the derivative of some k times x to the n, okay, I'm going to take k, again, k times n times x to the n minus 1. Right? I know that n minus 1 has to equal 9. And I also know that k times n has to equal 10. So again, I can, just like in the first example, go ahead, first find out what n is. N minus 1 is equal to 9. That tells me that n is equal to 10. So I know my exponent is 10. On the other hand, okay, k times n is equal to 10. Well, if n is equal to 10, whoops, okay, that means k times 10 is equal to 10, and that just tells me that, whoops, k is equal to 1. So again, my antiderivative is my coefficient's 1 times x to the 10th, or just x to the 10th. And sure enough, if I take the derivative of x to the 10th, that's going to be 10 times x to the 9th power. Okay. All right, for the final one, here we have just x squared. So if I take the derivative of some k times x to the nth power, that's going to be k times n times x to the n minus 1. All right, so I know that k times n equals my coefficient on x squared, okay, which is just 1. And I also know that n minus 1 has to equal 2. So n minus 1 is equal to 2. That tells me that n is equal to 3. So I know n is equal to 3. And then k times n is equal to 1. But k times 3, n is 3, so k times 3 is equal to 1. That tells me that k is equal to 1/3. So in this case, my antiderivative is 1/3 times x to the 3rd power. And sure enough, if I were to go ahead and take the derivative of that, 1/3 times 3 gives me 1 times x squared.